told y'all earlier, I just want you to focus on A and C. Okay?
Well, I was trying to answer this question.
Right, what part of the parabola shares the same value as C in the standard form? So go back. What is C right now? No, what, right, but what is C? It is, and where do we see 2 on here? So that's the Y. Okay.
Can you go to the drawing that has those sliders for the standard form?
Kind of. Let's talk about it. Thank you. Thank you. Alright, so I think a lot of us, we struggle with it. We didn't love it at first, but I want y'all to really notice something about A. A changes quite a few things actually in standard form, but that's because we don't know much about B. But when A is negative, what do we see about the parabola?
The concave down.
So remember, don't just say it's. What is concave down?
The
parabola, right? When A is negative, that parabola is concave down. What about when A is positive?
The parabola is concave up.
The parabola is concave up. So is A doing the same thing as it did in vertex form?
Yes.
Yes. A is A. It doesn't matter what form you're looking at, A is A. And we want to notice that, okay? So whatever you wrote down for, so which box should we be looking at for the key characteristics?
Concavity.
Concavity, right? So what you wrote under vertex form for concavity, where else should you write it?
For standard.
Under standard form, thank you, right? So whatever we wrote under concavity for vertex form is now what we should be writing under standard form. And I would rewrite that so that you have it a second time. And you emphasize, hey, that A is the same thing.
So whatever we write on the other.
So right here on concavity, did you not write anything about concavity on vertex form? So it's closer to this. A affects the concavity. If A is positive, the parabola is concave up. If A is negative, the parabola is concave down. You should have written that here yesterday. So you already have it written here. It should have been there, so just copy it over to there. Sir? You still, is there one more in there, or did you just take
Yeah,
one?
you still need to.
And so I want to point out, if you want to figure out concavity, what do you always need to pay attention to? The A. You got to know what A is if you want to figure out the concavity from the equation. Now the next question was all about C, correct?
Yes, sir.
Can someone tell me where we see C on the graph?
On the y-value.
Vertical.
Why?
On the Y.
We see it on the y-axis, the point on the y-axis, we're missing a detail there.
It's a y-intercept.
Now I want to pause and I do want to emphasize this, because Jakayla, you and I talked about this earlier. Is this value of C the entire y-intercept?
No.
Why not?
Yes, it is.
It's supposed to be a point,
It's supposed to be a point, right?
just like the one on the thing, right? It says
Oh, yeah.
0,5. It's supposed to be a 0 in front
Remember, a y-intercept is a
of point.
point. And what do we know about every y-intercept?
The x value is 0.
The x value is 0. If you don't write it as a point, you still have a slight misunderstanding, right? So you have to think about that on the rubric. You need to identify, hey, C is equal to 5, so the y-intercept, and this is only for this particular one, 0, 5. So first off, where on the graphic organizer should we be looking on that standard form?
X-intercept.
Y-intercept?
Remember which point did we just call this? The y-intercept.
Oh, but I thought you said that X always 0.
Yes, remember the x is always 0 for what point?
Why?
The y-intercept. Remember the x value is always 0 for the y-intercept, whereas for x-intercepts, the y is always 0, right? So we do need to keep that in mind. So we are looking at a y-intercept. How could I use this equation to write the y-intercept? Right? Not this particular one, this generic one, the standard form.
AX squared plus BX plus 5?
That's always the y-intercept?
No,
Come on, first off, if we're going to write a y-intercept, we need it as a point. So I need to start with parentheses. So under y-intercept, you would want to start with parentheses.
So 0,
So the x value is 0, the y value is
C.
c. Right? Whatever c is in that equation, that's my y-intercept. You might want to make a note to yourself. Y-intercept is always a point with, what do we know about every y-intercept?
X is 0.
X is 0, right? You might want to make that note to yourself to remind you of y at 0, comma c. Alright. Once you finish that, move on to slide 13. Work within your small groups. We should be able to get this one done a little bit quicker. Alright. After you finish slide 13, then move on to the next one.
By the way, Denasia, all this is in a Yeah. So I was asking y'all to fill out this graphic organizer so you have these notes to come back to later, okay?
Now, don't do it right now because we need to focus on this. But, so, make sure you're checking in with your group, see if they agree with you. But just a couple minutes to get slide 13 done. If you finish slide 13, are you going to just sit there?
yes.
No. You're going to go to slide 14. Great job, guys. Woo!
Yeah.
Say again.
When it's asking for the parabola, parabola, whatever you want to say, you looking at D, the A, or you looking at C?
What did we say?
The A.
The A. Because remember, what is C affect? What is the C? That is my, it goes with the y-intercept. Now, I want to pause and I want you all to look at this. What issue might I have with this y-intercept? Huh? Right. If you're going to do a point, you got to have those parentheses. Trying to make sure we know that before we have understanding checks.
Miss Ken, I think you should go to, she got that wrong.
We'll talk about it. Okay? I think for the most part, I know some people aren't quite done, but I do want to look at this. Does anyone want to push back on the y-intercepts at all, or are we all comfortable with this?
Let me see. Yeah, we comfortable with the y-intercept.
Okay. You are one person, that ain't no we.
Yeah.
Okay, you good? Anybody want to push back or ask questions? So we're all in agreement with these y-intercepts?
Yeah.
Alright? What about these concavities?
No, I want to push back. I want to push back.
You want to push back? Alright, so I've heard you talk a little bit. Alright, Kelsey, you're agreeing. I want to hear from you. Why do you want to push back on these?
Well, because they said that number 2 is up and then number 3 is down.
Okay? And I will say this. So you're saying that you think this should be down
Oh.
and up. And I think I heard quite a few people, I saw quite a few people saying this. Would someone who said that the second one is up tell us why you were thinking that?
Because I was still looking at the
C value.
y-intercept.
The y-intercept, right? And that's what you were doing originally as well, Jakala, right? But remember that C is only for the y-intercept. What has always affected the concavity?
A.
A. So we want to pay attention to A to figure out our concavity. So it should be up, down, up, down.
Damn.
Alright?
So only 14?
Alright, on to slide 14.
That's factored.
Yep, there we go. So the only form we haven't looked at is factored form. So which page should we be looking at?
The back on 74.
74. Okay? And so we want to keep in mind again, what is the first slide here, slide 14, asking us to look at?
Just the value of A.
Adjust value of A. We should probably already have a good idea. When you move on, right, we need to move on somewhat quickly so we can finish this today. All right, move on and then we will look at some more of these details, all right? Let's get to work. So work on 14. Anthony said, no, I don't even need to look at 14. I already know what I'm going to type in there. So Mr. Green. Wait, A is always going to do the same thing?
Oh, yeah.
Do you see it happening with this vertex form as well? Or this factor form, sorry, not vertex form.
I put A stays on the x-intercept.
A stays on the x-intercept. So what do you mean by that? So remember, don't just talk with me, but show me what you mean by that.
Like it stays right there.
Oh, well, so that means that A doesn't affect the x-intercepts in this form, right? But what we want to know is what does A affect? Talk about that with your small group. I'm going to go check on others. Talk about it with each other about what we think A is affecting.
When it's positive, I think it stays. The concave is up.
Once you finish 15, move on to 16. So Eli, what's going on, man? Huh? Yeah, you know you're missing important information, right? Yeah? Okay. What time did you go to bed last night?
About 6.
Before or after the game?
About midnight? You go to bed earlier. You gotta be awake if you're gonna learn in class.
So what you put?
And you're leaving your boy Kenyon out to dry. He can't even collaborate because you're not here to talk with him. Now, Kenyon, if you were talking during the whole class discussion, I might let that slide because it's on him that you're not able to talk. But I need you to start getting involved in the whole class discussions. Otherwise, you're gonna drop to those 3s on active collaboration. You want those easy points, man.
They do, yeah. Mr. Kent, let me ask you, I want to jump the baby, never mind.
What?
So we move both of them. But this is saying move 8, so do we move both of them on 6?
Oh,
Just
that slide 16 should say R1 and R2. It doesn't? Hey, really quickly, I made an error and I'll have to fix this in future times we use this. But slide 16 should say adjust R1 and R2.
Yeah.
that's how
It says A, that's my mistake, I'll need to update that in the future. But slide 16, you should be adjusting R1 and R2.
It can never go up though, I tell you
But where do you see R, so I'll say this, R1 and R2 show up somewhere very specific on that graph.
Oh, well, yeah. it's-
Change, so we do see it on the x-axis, so go on, think about some other words we can use to describe that. Slide your R1, move it. And how else could I describe the R1 and R2? You say the x-axis, what do you mean? Slow down, actually, they're intercepts? What are those points called where we intersect the x-axis?
The whole thing.
Huh?
X-intercept.
So it,
They are points, so what kinds of points? What points intersect the x-axis?
axis twice. R1 is the first x-intercept, and R2 is the second.
What are those points that intersect the x-axis?
How you supposed to do that R1 like that? I'm confused. I put it in so I just put R1.
I'm asking you what point intersects the x-axis? Would a y-intercept intersect the x-axis? You're looking at me, look at these here. Which point do we talk about when it intersects the x-axis? What's the point called where we intersect the y-axis? When it intersects the y-axis, it's called a y. So what's the point?
But it's always a zero.
Huh?
Ain't it always a zero?
What part's always a zero? For an x-intercept, what's always zero? The y value is always zero for an x-intercept.
And go
So R1 and R2 tie into the x-intercepts? Type about it.
I don't know.
Yeah.
It's gonna be really hard for you to see. Zoom back in. You want to? Have y'all talked about R1 and R2 at all? What are y'all seeing there? As the what? What x?
So y stays 0.
Oh, okay. Do you see the same thing there? Where the R1 and R2 are your x-intercepts? Okay, then go to slide 17, type about it. If you see it, move on.
Be careful. The y value is always 0. Because remember, the y-intercept is where we intersect the y-axis. And you have to be careful about that difference, because that'll confuse you in the future. So the y value is always 0, right? And then, so what kind of point always has a y value of 0? Look at your key characteristics. What characteristic has a y value of 0? Look at your key characteristics.
Oh, the x-intercept.
Oh, so you're telling me that R1 and R2 tie into the x-intercepts? Is that true? Do we see? So go back to slide 16. Is the R1 one of your x-intercepts? Is the other value the other x-intercept?
So the y changes like.
What are y'all looking at? What are y'all confused on? Yeah, let me ask you this, does the value R1 show up anywhere on the graph?
Oh, what about somebody?
Well, only sometimes. Move the R1 again to -2. Look at
Oh, okay, let's go right there.
Similar to what I did.
What they say?
Yeah, that might be
that -5 comes into the vertex. Okay, so where do we see the value of R1 and R2 on that graph? So look at the numbers for R1 and R2. Where do we see it on the graph? Do you see that R2 number?
Yes, and I don't know what.
Wait, the purple dot is which one, R1 or R2? R1, and then the black dot is R2, right? What are those points called? Yes, you do. Look at your key characteristics. Look at your key characteristics. Look at your key characteristics. Which point are you looking at as intersecting the x-axis? Don't feel we are on factor.
What's about number 18?
Hey, quick question. What's the point called where we intersect the y-axis? The y-intercept? So what's the points called where we intersect the x-axis? Oh.
And then you have to like click
Because
out.
remember, what's the only one we haven't talked about yet? The x-intercepts, right? Yeah.
Can I write it like this?
We're gonna go over it in a
I know
second.
that, like, how you write it.
No, and we're gonna talk about that actually. We'll talk about it. I like the ideas. Thank you, thank you, thank you. All right, so let's talk about this one a little bit. Do I even need to go over A? Yes? Okay, let me ask you this. When the value of A is positive in factored form, what do you know about that parabola? Oh, it's concave up. When A is negative in factored form, what's concave down?
The parabola.
The parabola. We need to work on that language, right? So, again, if you can identify A, you automatically will know that concavity. I need you to hear me very clearly. Concavity is the only feature that shows up in all three equations. Concavity is the feature you can easily see in all three equations. In vertex form, what other features could you easily see? In vertex form. The axis of symmetry was easy to see in vertex form. What else? Oh, and the vertex, right? It's called vertex form. When we looked at standard form, we saw concavity. What other feature can you easily see in standard form?
The x-intercept.
Did we write about the axis of symmetry under standard form?
The y-intercept.
We only wrote about y-intercept, didn't we?
Oh, yeah.
So, on standard form, I will ask you about concavity and the y-intercept. What features are we seeing here in factored form? Well, we still see concavity, right?
X-intercept.
And x-intercepts? So a lot of us started to notice, I want you to look here. R1 right now is what, -3? And R2 is 1, which I noticed some people are talking about, hey, the red and the purple dot are the same as R1. Okay, so let's change things a little bit. So, it's not now. Notice the -3 is this purple dot, right?
Yep.
And the R2 is this black dot. So, here's a little bit more clear understanding. You can find the y-intercept really easily. What's -3 times -1?
3.
Notice if I multiply the x-intercepts, I get the y-intercept. And so that's what one thing I would notice, and we'll talk about y in a second.
Can you do that for each one, every one of them?
If you're in factored form, so notice now R1 is -3, R2 is 3, and what's the y-intercept? 0, comma -9, right? We get with that idea?
Like, will we always have like a little form, like a little form up there?
Say it one more time.
Like, will we always have like a form or that, like, how will we know?
You have to know what form it is. So like when it's written as a times x minus h squared plus k, you will need to recognize that that's vertex form and that you can find a, h, and k.
Do you have like the formulas on the board?
No. Y'all gotta know these forms.
Hold on. Can you write them all up there real quick so I can write them down?
You know they're on the graphic organizer, right? At the top?
Oh, my bad. Hey.
No, I'm not trying to kill you. Do y'all know slope-intercept form of a line?
Yeah.
Yes. Did you always know slope-intercept form of a line? No. You had to take time to learn that equation. In the same way, you need to know this equation, okay?
You're going too many equations.
So, like,
3! Oh my gosh, it's 3 equations!
So, like,
Mr. Kenny, it's so much!
No,
Yo,
we
what-
learned, hold on, we learned y equals mx plus b. We learned that because it was one equation, not 5 different equations.
It's 3. 1. It's 3. You're in high school, right? Y'all are juniors and seniors in high school.
Alright.
If you want to go to college, you better learn how to learn 3 equations in a couple days, okay?
In a couple of days.
Yes.
Mr. Kenny.
Y'all have, I will say this, we're going to have an understanding check on Thursday, but like y'all have until next Thursday or Friday to master this before the test.
I ain't ready.
Okay? Yes, ma'am.
Right, what a, like,
Hold on.
you see how they got, like, the vertex has minus and the standard form has plus, like, will it always?
We're going to talk about that, okay? Well, and so that is actually a good note. Really quickly, I do want you to hear. Remember, right, with standard form, it's always plus, but if you add a negative, what's going to end up happening? You're going to get subtraction, right? And so it's just the standard thinking about it. Here, if I subtract a negative, that's going to become a plus. So you need to notice, whenever it's a minus, you end up getting the opposite. And when it's a plus, it's just whatever sign is there, right? So if I get y equals 2x squared plus 3x minus 4, well, because it was plus c, that means the y-intercept is 0, -4, right? Because it is just whatever's there. It's when we have the x minus something, right? When we had x minus h, we had to do the opposite of whatever was there, okay? And so you do need to be aware of that. But I will point out, the only time that it's the opposite is when it's x minus. X minus. So whenever you have that value with an x, it's going to be the opposite. Okay? So, we do want to notice, or what should we write under x-intercepts?
The y,
So,
always 0.
so 1, what part of the parabola shares the same values as R1 and R2? They are the x-intercepts, right? And so we would want to say, hey, that y value is always 0. Now, here's the thing to remember, and I already saw some students making this mistake. how many x-intercepts were there?
2.
2. So how many points should I have?
2.
2. Notice it's going to be R1, comma
0.
0, and
R2, comma 0.
R2, comma 0. Remember, they're x-intercepts. It's not 1 point, it's 2 points.
I knew that, but I ain't gonna like
But so we need to write it like that though, right?
Did you really?
Pushing on that a little bit. Alright, so one thing I do want to point out, does anyone find it odd that we're using the letter R for x-intercepts?
Radius.
Not radius.
I do.
Rational.
The another word for the these values are called roots. We'll go into more detail about it, but the x value of the x-intercept is also called a root.
So like, to my root out of plant.
Actually, y'all laugh. I did a lot of research because I was really confused where the word root came from, and it did come out of something to do with plants. No one really knows. This is one of those weird things where someone used this term once upon a time, and we don't know why or where, but that's how it came about. So it took me like 20-30 minutes trying to figure out where the word root came from, and the closest I could find is something to do with the root of a plant. No one knows anymore.
What the world?
Okay, but another word for the so the roots, and there's a specific case that we use the word roots, but in general the roots are the x values of x-intercepts, and that's only partially valid. We're going to look at other cases where the root is not an x-intercept, but we'll get to that later. For now, know that R1 and R2, we're going to talk about those x values of the x-intercepts. Any questions before we move forward?
No.
Do we need some practice with this factored form?
Yeah.
Okay, so go to slide 18. Work with each other on getting the x-intercepts and the concavity. Okay, then go to slide 19. Yes, ma'am.
So,
You have to swap them.
Solve it in small groups. Solve it in small groups.
ain't this gonna be 2 points?
I did not.
But what?
Yeah.
So I do.
Okay, what did we just say about it? Because it's x minus R1 and x minus R2, so we need to what?
That's gonna be.
So positive 3, but then the 7 would be
How did you do yours?
negative.
And it's gonna be 0. No, the number.
We talk about it because Omar already on something there.
R2, comma 0. Those are two different.
Have you talked to your small group yet? Do that.
So, Christine,
Yes, ma'am.
isn't it gonna be 2 points, right?
What do y'all think? 2 points for the x-intercepts? Yeah? Okay.
So like, we're like, asking like, this is right.
Talk to your small group. So what do y'all think for the x-intercepts? 3, comma 0 and 7, comma 0?
Negative 7.
Why are you thinking that?
Okay.
So it was x minus R1 and x minus R2. So talk about that. And you're thinking opposite. See if they agree.
What now?
Do it. Like, it's already the opposite.
You put down.
Standard, right? Do you only do the opposite of right? Oh, yeah.
I don't think the order
Actually, in the
No, the order doesn't matter. It's okay.
So
Record.
remember it's x minus R1.
What do I put in?
Because in the formula, it's x minus the root, right? So if
Yes,
the
but
root
there was an O word.
is on the negative 3, that's gonna make it x plus. The same thing how it was with the x minus h in the middle.
See how it's
When that h was negative, it made the formula x plus 8 or x plus
So is it the
3.
opposite?
So like if it gives you an x plus, it's negative.
Because how many x is
And also like you
might cause a little bit of confusion on the last one. Talk about it. Huh?
So it all connects, it all comes together. We're getting there.
I forgot a I.
I finally used something.
This is
Now symmetry.
We'll be like tomorrow, so.
Well, I won't be here, so just want me to go ahead and pass this out.
Oh, yeah, that was it.
Hey, Kenny, I don't get number 19.
Slide 19. So look at your graphic organizer, which features were you able to easily see in each form? So in vertex form, yeah, so just yes or no. So were you able to see concavity in vertex form?
Oh, so you look for yes or no all of them?
All of them, yes.
Now, yeah, that's all I'm asking you to pay attention to. Yeah.
So what do you guys notice about the x-intercepts in relation to?
And you
I already passed this out to all of you.
Isn't it the vertex?
So like
The
this
vertex
x-intercept
number is just that
3
one.
here, but in here it says x
Yeah.
minus.
See, I'm getting a little mixed up.
I know, it's a lot, that's why we need practice with it. We'll be practicing with it. One, you'll have some mathy assignments, not this, but mathy assignments. I'll explain in a second, that's why I'm passing it out now.
Are we turning in the graphic organizer?
No ma'am, that's for you to learn from.
I'm glad y'all see that.
Yes, the blue graphic organizers, yes.
Here you go. I just asked you about it, you said no.
Oh, I thought you were talking about the graphic, I already picked up those graphic organizers, I thought you were talking about the other one. Alright, thank you. Hey, this is a good point, if you missed it earlier, I did already collect these blue graphic organizers, you should have the full front page done. If you don't, and you finish it during enrichment, you can bring it back and it's not late. Now, I need everyone's attention, alright? So let's look at,
Students, please mark your interruptions. The bell rings and includes the following people in front of all. Olivia Levy, James Martin, Marcus Webb,
okay?
Robert Jones. Thank you.
Let's look at concavity. Do we want to push back on this student's responses for concavity at all?
No,
Up, down, down, up?
no,
We all good there?
yeah,
Does anyone want to push back on any of these x-intercepts?
no. Yes, on the last one.
This one
No,
here?
cause the last one ain't got no other points, so it's all on one point.
Yeah, all on right. No,
I mean,
no,
the
no.
negative 7, the negative 7, and negative 3,
And -3?
No, it's positive, it's positive.
So remember, and this is a detail. One, how many points are there?
2.
2. And this is something I want us to pay attention to, because some students were a little confused on this. Because it's x minus r1 and x minus r2, we need the what?
Opposite.
Opposite, right? X minus 3, so it's a positive 3. Now, I want to pause for a second. We already talked about this, actually. There's supposed to be how many x-intercepts? 2. So where's my second one?
You still gotta put it, you still gotta.
It's 0, 0.
See, and this is what I want you to actually notice. First off, this should remind you of vertex form. So the vertex is 3, 0. Because the vertex is on the x-axis, how many x-intercepts do we actually have?
1.
Only 1. And that's okay. But also, I do want you to notice, x minus